So this is going to be probably a fairly lengthy walkthrough regarding how to set up Eclipse for Python development in Docker containers. It's a little bit complex, but it was quite important to me to figure this out in order to achieve the kind of full promise of Docker, which is really that from development to test through to production, the environment is absolutely identical, and therefore you've got this much greater security that things are going to work in production same as they worked in development and test. And also there's a lot less work involved in taking a project through dev to test to production, and it shortens your cycles. So let's get started. And the first thing we're going to do, I guess, is create a Python project within Eclipse. So I would come here and say File, New Pydev project. We're going to call this, let's call it Pydev Docker 1. And we're not going to define the interpreter yet because we're going to create an interpreter and then use that interpreter within this project. We're going to reference another project. So in my case, I've got some general purpose modules which do certain things for me, like logging, that I use from project to project. Now, if I were a more professional programmer, I would already have these installed in some way such that I could, set up in some way such that I could install them using pip. But I don't. That's next on the list of skills that I need to master in relation to Python. So I have to refer to another Eclipse project rather than installing the result of that project through pip. So I'm going to refer to my general project, and then we're going to finish. So now we have our Pydev Docker 01 project. And if we go to the command line, and we go to the top of my Eclipse workspace, we see we have Pydev Docker 01. Now, whenever I'm doing a Python project in Eclipse, I like to create a dedicated custom Python environment, or just for that particular project, which allows me, first of all, to keep track of the packages which I install for that project, and secondly, to only install the needed packages for any given project to an associated interpreter, and to stop myself from contaminating the standard Python interpreter on my Linux system, which is needed for all kinds of general purpose aspects, such as managing Linux distribution updates. So we're going to go into this Pydev Docker 01 folder, you said. Oh, so I've got a cd pydev pyd. I can't believe actually. So cd py. Good start here. Now the first thing I want to do is I want to use a tool called pyenv to set up the version of the Python interpreter I want to use within this location, the location of the project. And I've got some notes, which I'll go and refer to here. So I want to use 3.8.1, and here are my notes. I use the command pyenv local 3.8.1. Now, this is not going to be a pyenv tutorial, but to summarize, pyenv is a tool which allows you to pick the Python interpreter version that you want to run for any particular project, you actually associate it with a directory, with a location in your file tree. And the basic workflow is you initially install PyEnv. Then, having installed PyEnv, you install the versions of the Python interpreter that you want to have access to within the confines of PyEnv. So remember, you will have your standard system-wide Python 3 and Python 2 interpreters, and you don't want to mess with those. So I've already installed PyEnv, and I've already installed the 3.8.1 interpreter. And now what I want to do is to say that within the confines of Pydev Docker 01, I want to use that version of Python. So we will Control T here, Control V there, and okay, now if I type Python, actually I just realized I've got to do something here. I've got to, yeah, I was actually, I'd forgotten that I was already operating within the confines of another virtual environment. So let me go, now that should still, that pyenv command should still have taken effect. Yeah, so I'm in Python 3.8.1. So let's, before we move on, let's see where that Python interpreter is. And it's actually, you can, because it's under pyenv shims/python, that tells us that, yeah, this is a pyenv related interpreter that we have here. So we've picked an interpreter version, but now based on that interpreter version, we want to set up a virtual environment and manage the packages which are installed into that virtual environment. So the tool that I'm currently using for that is pipenv. Now, we've already got pipenv installed against the this 3.8.1 interpreter, and I think if I type something like pip list, you'll see that pipenv is there. So if it were not, I would do a pip install -- upgrade pip, and then a pip install pyenv. But we already have it installed, so we don't need to go through those steps. Having installed pipenv, we want to use it to create a virtual environment. The way that we do that is we type pipenv shell, and you can see that the prompt has changed. On the left, in parentheses, we have Pydev Docker 01, which is effectively our virtual environment. And you can see from what came out that our virtual env location for the virtual environment, which was created by pipenv, is home/ed.local share virtual envs Pydev Docker 01 and some random text. Okay, so we are now within a 3.8.1 based virtual environment, and if we type pip list here, we'll see that we've got a minimum installed here. What comes essentially with pipenv, we just have pip itself, setup tools, and wheel. So at this point, we have our custom Python interpreter defined. Now you'll notice that I have defined this outside of Eclipse. Eclipse has stuff in its GUI which theoretically allows you to define a pipenv interpreter, but in fact, it doesn't work all that well. So to carry on here, so we have our virtual environment installed using pipenv. A little word of warning, as I was investigating some stuff to do with pipenv today, I saw a lot of people talking about how the pipenv project has kind of ground to a halt and seen no further development. Apparently the main developer has lost interest or maybe having some personal problems or something like that. or had some problems in his relations with the potential contributors to the project. So in any event, how do we install packages within pipenv? I believe it is simply pipenv install. And the only package that we want for this example is actually the Pydev D package itself, which is going to allow us to do the remote debugging. And in fact, we don't actually need that here, which will become clear later, but we're going to install it. Okay. Okay. This is a little bit slow for me. Guess it's working off of a Comcast service at home, but it is going to install. In fact, it didn't. So let me pause this while I resolve that. This didn't happen. Okay, so I've been working on this for a few minutes now, and don't know what to tell you. I created my virtual environment and tried to do the pipenv install pydevd, and it was consistently giving me problems, complaining about dependencies. And what I ended up doing was completely exiting out and closing down my terminal windows, then going back in. Just going back into the same directory, typing pipenv shell and then pipenv install pydevd, and this time it has worked. So I guess that's not a good advert for pipenv, but we're going to continue with it. I am going to be looking at an alternative called Poetry, which I've seen recommended because, as I said, pipenv looks to be on shaky ground. So in any event, we now have our virtual environment set up using pipenv. The advantage of it being that we have our dependencies in these pip files. So we've got the pydevd under packages, and if we don't really pretend to understand this, but this actually has the hashes for the packages, so that to make sure that you actually are installing the correct package version and stuff like that. So that's installed, and what we have to do now is we have to associate the Python interpreter associated with this pip environment with our project. So first thing we have to do is we have to add in that Python interpreter into Eclipse. We're already under Pydev interpreters Python interpreter here. And what we're going to do is you'll see that it says new with pipenv and stuff like that. I found this pipenv stuff isn't working well within Eclipse, and I prefer to do it outside of Eclipse and then add it in manually by browsing. Now, the virtual environment is actually located under a .local file in my home directory, and when you go into this Explorer dialog, it's not showing you hidden files. You have to type Control-H, and below, hidden files show up. I guess we can organize by name, and we will see our .local share, virtual ems, and we've got our pydev docker 01 bin, and we will just find Python. And we will call that our, let's call it Pydev Docker. Okay, so we give the interpreter a symbolic name. And these are the folders which we will add to the Python path. The first two are related to the 3.8 interpreter, 3.8.1 interpreter. And the last one is related to our virtual environment. Apply and close. So we've added that interpreter into our Eclipse Pydev environment. And what that means is it's an interpreter available to be associated with the project. Now what we have to do is associate it with our Pydev Docker 1 project. And we do it by going to the project, right-clicking, and then properties. And we will see the interpreter, and we will select Pydev Docker as our interpreter. Okay. So with that, we have basically got our project set up within Eclipse with the custom interpreter that we want, having picked the version with PyEnv and having set up a virtual environment for it with pipenv. The next thing that we need is we essentially need a test program that we want to deploy to Docker. So what I'm going to do is I'm going to do a new package. Let's call it PDD. Okay. And within that package, I'm going to create a module, which we'll also call PDD. And what we'll do is we will pick a standard template, which is going to be the arg parse command line template, just to give us something to execute. Okay. We're going to make some changes to this script to make it suitable for our purposes. And I'm going to pause while I check what those changes are. So with reference to making the changes we need to make to this script, I'm going to look at one I prepared earlier because I'm kind of repeating this. And what I can see is that we need to import the pydevd module, the JSON module, and the logging module. So we're going to copy these out of here and replace this where we have sys and os already. Okay. We also need to have these calls. Now, just to explain, that is actually just me using this this other project module, which I referred to when I created this project. I basically want to make sure once we're debugging that I can jump out of my main script into another module and set breakpoints in that other module. So I've just called this, imported this general purpose module, which is used to set the log level for the script execution. So I've imported it, and then I've called the function set log level with the warn string. I actually realized that we don't need to import JSON. We're not using that. The other thing that we want to do is we want to actually potentially turn on Pydev debugging. Okay, and so we're going to copy this piece of code in, and that could essentially go at the very top. And just to explain this, do we import? Okay, we need the OS above that because we are actually referring to that module. To explain this, we're going to use an environment variable debug, which will either be set to 0 or 1, in order to indicate that when running the script, and we will be running it inside a Docker container, whether we want to connect back to the PyDev debug server running within Eclipse or not. So the first thing we do is we retrieve the value of that environment variable debug. If it's not set, then we will default the value that goes into the debug on variable as 0. Then we will check that debug on variable, and if it is set to 1, we will call pydevd.setTrace, providing this IP address. The 172.17.0.1 is the IP address of the host machine that is running a Docker daemon in order to service Docker containers. And that will become, what that does will become apparent a little later. So let's save that. And just to give you an idea of a very simple execution of this particular script, which is pdd.py, let's go into our terminal. So we'll go into pdd, our package. Here we have our pdd.py. We should be able to type Python pdd.py and -- version. Let's see what happened here. Okay. So it looks like I haven't included a reference to my other project as I thought I had. So we will come over here and check that. Properties, references. Yet it is supposed to be referenced. So that's a little bit surprising. Let's try that, and then let's try it again. Okay. What's surprising is that this is not this hasn't caused any complaints here. And if I were to type from general, that's there. Dot setlog is there. Import setlog level, so it can definitely see that. Let's go back and look at the message again. So it's saying no module named general. Okay. So I'm going to pause again while I figure this out. Sorry for all the pausing, but this is live. So what I did here was I decided to try and check on the Python path. So before trying to import this particular module from general.setlog import setlog level, I just realized what's wrong. I just realized exactly what's wrong. Being a silly boy. So what's wrong is that the Python path within Eclipse includes the general module, but if I try to run the program outside of Eclipse, then I don't get the benefit of that reference, so it's not in my Python path. So what I need to do is I need to append that that particular path to my Python path. So let me just figure out how to do that, and I'll be back in a second. So I figured out the path to that particular module. And this Python path will be appended to the standard set of locations for finding modules. And I now believe if we try to run this, what actually happened is we printed out my Python path, and then we printed out the version of the script. So let's go back here. Let's take out our sith path printing. Let's run that again, and we simply get the version. So that is essentially our script running, and all it's going to do for us is print out the version. We really don't care about it doing anything more than that. But at this point, what we want to do is we want to get this script deployed onto a Docker container and to run and debug it on the Docker container. So what we're going to do is we're going to create some additional directories under the Pydev Docker 01 folder. So we've come up to the top level. You'll see that what we have here is our PDD package with our pdd.py module in there. And we have our pip files for the pipenv virtual environment tool. So what we're going to do is we're going to make there, and it's going to be called Docker. We're going to make a directory Docker. We're going to make a subdirectory modules. Okay, and we are going to go into Docker. In fact, we're not going to go into it. We're going to create a file in Docker, which we will call, which is always called Docker file, which is provides the instructions on how to build a container image. And the first thing we have to do is tell it the source or the base image from which to start building our container. Now, I have up until now been using a base image based upon the Alpine Linux distribution, which is notable for being very small. But I read something today which prompted me to decide to switch over to something other than Alpine, and it's going to be Ubuntu, because it was highlighting potential problems with Alpine. And these are problems which I've actually seen myself in complications in using the Alpine distribution, and even down to the potential for strange errors and bugs. The other things were longer build times and not getting the image size savings that you might initially think you were getting. So when the bare Alpine image might only be 10 megabytes as opposed to 100 megabytes for Ubuntu, but once you've actually built a functioning container image, it's probably going to be much of a muchness. So I need to figure out which Ubuntu Ubuntu-based Python image I want to use, and I'll be back in a second. So I'm going to include this. So I've gone to the hub.docker.com, and then it's /_/Python, and I figured out that what I want to use is so basically you're going to pull down an image, and it's going to be Python, and then you could qualify that with a colon and then some tags. The one I want is 3.8.2-slim. So come over here from Python 3.8.2-slim. What that's going to do is, for now, we're just going to create that Docker file. We're going to do a Docker build command. We're going to tag it as squinkly01, which is my ID. And what are we going to call this? Pydev. Pydev Docker 01. We're going to reference a file, which is docker/docker file, which is where we're going to find the Docker file giving the instructions. And we're setting the root of the build environment to be the current directory. Okay. So I got a problem there. Okay, so it seems like you can't have an uppercase, so let's try that and see if that is what the problem is. Yeah, that's all it was. Didn't like an uppercase letter in the name of the tag of the image. So there we built our container, and so that's called a Squinkly 01 Pydev Docker 01 : latest. So just to give you a simple notion with this, we're going to Docker run. We're going to say --rm, which means remove this container, delete this container once we're done. So we'll call this Docker 1, and we are going to use the image. What we're going to do when we get in there is we're just going to run the shell, which is --bin. Okay. Oh, my mistake. Bin is with Alpine. I'm assuming that Ubuntu has the bash shell. Just to explain, the Alpine distribution doesn't come with the bash shell as standard, so I had to specify bin bash, which is what comes in Ubuntu, and now here we are inside of that container. Let's see what our Python version is. It should be 3.8.2, and lo and behold, it is. Okay, so what we're doing is we've started a container, we dropped that into the container, we're running the shell, just to make sure that that worked. Okay, so we just come out and we've actually exited out of the container, and we don't have any running containers. It was deleted. We have some containers here, but not that one. Okay, so that was step one. Now I'm going to refer to my documentation here. So the next thing that we want to do is we actually want to install some Python packages. We definitely need to install the pydevd package, and again, I'm going to refer to my another project to see exactly what we did or what I ended up doing, because anyway. Okay, I'm sorry if I seem a little bit uncertain, but this is the second time I'm going through this process, and what I'm trying to do now is kind of rearrange the order in which I do things based upon a lot of discovery. So here's what we're going to do. We are going to edit the Docker file now. Add in a couple of lines. The first thing we're going to do is we're going to set this debug environment variable. So this env debug 0, what that will do is when the container is launched, that environment variable will be in the environment, the execution environment, set to 0. The next thing we're going to do is remember that this is a container image which already has Python. So what we're going to do is we're going to make sure that pip is up to the latest standard, and we're going to install the virtual env module or package. Now what that tells you is that I'm going to then create a virtual environment for my script to run in. And that's not strictly necessary within a Docker container, but it is necessary when what you're trying to do is to be able to debug a project, an Eclipse project, when it is running inside a virtual container. So those are our next two lines, and we're going to save our Docker file, and we're going to rebuild. And what you'll see is that Docker builds up an image in layers, and it started off with the base image, created the debug environment variable, and then went through the installation of our modules, and also went through the installation of the packages rather upon which the packages we specified depend. So, virtual env would appear to depend on 6 and distlib and file lock and appders, etc. Okay. So the next thing that we want to do, I'm going to refer over to this Docker file that I already built, is we're going to want to build a virtual environment within our container. So in order to build a virtual environment, we need to know the packages, the custom packages that need to be within that virtual environment. And those will be determined based upon the packages that we install into our virtual environment on the workstation. And those are shown in the pip file and pipfile.lock. That is where we get that information. And the way that we figure that out, if I can find it in here somewhere, is the command pipenv lock -- requirements, and we put that into a requirements.txt file. So the lock is an option on the pipenv command, and we're going to take the -- requirements and put them into requirements.txt. If we cat requirements.txt, all we really have is pydevb. So we've got this requirements.txt file at the top level of our Docker build environment. Okay, and now we are going to edit our Docker file. And we're going to add in another couple of lines here. First one says, take that requirements.txt file that we just created and copy it into the /temp folder in the container. The next one says, run these commands inside the container. Change directory into /opt, run a command virtualenv virtenv. What that does is it will create a virtual environment inside the opt directory and put that virtual environment in a folder virtenv. The next thing we do is we run the activate command of that virtual environment to activate the virtual environment with the source, and then we find the binary activate. Having activated the virtual environment, so now we are any Python commands, any pip commands will be executed within the context of the virtual environment. We change directory into the temp directory /temp, where we have our requirements.txt, and then we run pip against that requirements.txt file. Okay, so we're going to rebuild. Okay, and we've had a little issue here. Now this is down to me having converted from Alpine to Ubuntu. So once again, we got a little problem to solve. I'm going to have to pause the video. So the problem I had is due to the fact that within Ubuntu, the shell executing the commands is the Bourne shell, or /bin/sh, and source is something in the bash shell. And apparently you don't put source for The Bourne shell, you just put dot and then space file name. So we're going to have to edit the Docker file and see if that works for us. So here we go. Seems a bit strange, but we're going to have to replace source with dot. Search dot, okay. And we're going to try again. It seemed like it worked because we're already installing PyDevD, which means we were able to. Okay, so we've been able to create a virtual environment. All right. Go back to my notes. Now, one of the things that we need to do, so we're trying to run the PyDev debugger remotely. So basically, our script is going to be trying to connect back to what's called a debug server, which is running within Eclipse. I'll just show you that. We're in Eclipse. We go into the debug view, and I can terminate and remove, I think. Okay, what I can do is I can start debug server for PyDev, and this is now listening on port 5678. And if we go over here and hit a new tab, we can telnet, and this is of interest, 17.0.1, which is the Docker address of my workstation, 5678. And that is the debug server, which is listening. So we need to be able to connect back from inside the Docker container to that debug server. And if we go back to look at our code again, you will see that we have put this IP address, which is the IP address at which the Docker container can reach the debug server. We've put that into our code. But the other thing that we need to do, basically, we are running what is a kind of compiled Python interpreter bytecode inside the Docker container. And that has to be mapped or matched up to Python source code so that as you're executing the script in the container, the debugger can follow along and show you where you are at in the execution of that script at a source code level and show you the values of variables. I'm not going to pretend that I understand that in too much detail, but basically, when that remote process contacts the debugger, there has to be some dialogue about what program is being executed. And the Eclipse and PyDev and its debugger have to be able to find the matching source code in order to get in sync. And the problem you have is that within my workstation and within Eclipse, I am running within a directory which is my home directory / Eclipse -workspace -project, etc. Whereas on the Docker container, I'm actually going to be running in a location which is /opt/pyscript, and also the various modules which are being imported into the script are also in different locations between the workstation and the Docker container. And so what you have to do is you have to provide a mapping of those different locations. And so what we're going to do next is we are going to look at the definition of those mappings. And this is this piece of code here. And what we're going to do is we're going to take this and we're going to put that into our Docker file. And I'm going to try and explain it to you. Okay, so the first thing we have here is what I'm calling the system base path. This is in relation to the path where most of my libraries are installed for the 3.8.1 Python version, which I'm running on the workstation for this particular project. So just to illustrate that to you, if you remember, we specified that within this location, we are running the Python 3.8.1 library. At the moment, I'm not running any kind of a virtual environment here. I'm just running that specific Python version. So in order to figure out what the various locations of effectively the Python path for the interpreter, we have to import sys and then get sys path. So you can see that we've got 1, 2, 3, 4 locations in here, but they are all under home.ed.pym version 3.81/lib. Everything else is under that. So if we go over here, I have this argument system base path, which is that home.ed.pym versions 3.81/lib. Now, what is an arg within a Docker file? Well, when you define an arg, what that will allow you to do is when you start up a Docker container, you can pass in a value for that arg dynamically when you start the container, but you can also set a default value so that you're not obliged to set a value for that argument. So the default value we've used is the one that fits my situation, this home.ed.pym version 3.8.1/lib. And once you have defined an arg, you can then refer to it elsewhere in your Docker file. And I have referred to it, as you will see here, using $ and the name of the argument. Okay, that's the first one. Now, because we have set up a virtual environment, and this has now made me realize that this is actually going to be, needs to be changed. When you set up a virtual environment, you get a unique location for the packages that you are going to install into that virtual environment, and that is going to go in as the site path argument. But what I've realized is that I don't currently know what that is. So I'm going to switch into my virtual environment. Okay, and I'm going to do the same thing. And you will see that previously up here, I had this standard location for site packages. And now I have a custom location relating to my virtual environment for site packages. And what I need to do is copy that and overwrite what I had in my Docker file, which was referred to a different virtual environment. Okay. And once again, this is called site path, and we actually refer to this further down. Now, in order to facilitate remote debugging, we have to provide mappings for essentially the locations of Python modules inside the Docker container back to the equivalent locations on the system which is running the debug server. And so, again, this needs to be changed because what I pasted in was correct for another project. So it's no longer Eclipse Workspace RDT02 RDT. It is now, if we exit out, Pydev Docker 01 PDD. So that is my the location of my main script in my workstation, and that is equivalent to /up/pi script in my Docker container. And by the same token, this is no longer PDT02, but it is now Pydev Docker 01. And that actually leads me to believe that it might be a good idea to also have arguments for those, so that I'm not having to edit my my Docker files so much. If I had an argument here, I would simply be able to change that value at the top, and it would be automatically updated here. So basically what we have is a list of directory mappings. The first one is for our main script. The second one is for the custom modules that we want to include. The third one is for like the interpreter level libraries, and the last one is for our virtual environment. Okay, and what we need to do is at least make sure that there isn't a problem with the format of this Docker file syntax. So we're going to write this out again and rebuild. Okay, and now what we can try to do is Docker run. We're going to go in and run this docked into a shell. Now we can look at our environment variables, and we will see that our debug is set to 0. And we can see our paths from Eclipse to Python environment variable, which is there. So those are the two that we were concerned about, the ones that we are trying to set, debug and paths from Eclipse to Python. I'm going to have another pause here while I figure out what it is I want to tell you next. So really looking at the reference Docker file, the one that I prepared for an earlier project, we've got two major things to do. First of all, we need to get our custom code into the Docker container. And finally, we need to make sure that that custom code will be executed using our virtual environment, the Python interpreter in our virtual environment. So with regard to the custom code, we've got a couple of lines which I've highlighted here, which are from the previous project. So we're going to take those and put them into our Docker file we're working on. So the second line is standard. Basically, what we do when we're preparing a build environment for a Docker container is that any of our own reference modules that we've developed that are in Python projects that we want to include in this project, we're going to need to physically copy them into the same directory. And there's a reason for that. I tried to symlink, and you can't symlink. So that's the second line, and we put all those modules under Docker/modules, and then we do a copy of everything that's under Docker/modules and copy it into opt/pyscript/modules. And we'll see that happen once we run the build. And the other one is, so let's go back over here, and we're in the container right now. So we're going to exit out of the container. And just remind ourselves. So the script we want to run is under PDD, and it's called pdd.py. So back over here. Sorry, from the insert mode here. So I'm using the Vim editor, and I'm not all that skilled with it anymore. I used to be quite skilled with it, but I'm not anymore. If you don't know Vim, I wouldn't attempt to understand what I'm doing. Okay. So what happens there? Anyway, let's try again. D slash doc slash pi. Okay. Okay, so next. pd intex of slash pdd.py. So we're going to copy our pdd.py script from the project, essentially source folder, over into the opt.pyscript directory in the Docker container. And we're going to copy our other module dependencies into opt/pyscript/modules. Okay, so that's the additional stuff in our Docker file. Let's save that. Okay, so we do ls docker. See, we got modules. Let's see what we have in modules. Got nothing in there right now, and we need to bring across this general module that we have. Now, what I need to do is I need to copy across the modules from other parts of my development environment and have them inside my Docker build environment, because you can't symlink outside. The reason for that is that once you start symlinking, you start to lose portability. You have to make sure that if you're moving around this Docker development environment, that everything that's needed goes with it. Because typically what you might do is upload the whole of the Docker development to a Git repository, and then someone else would pull it down somewhere else. So they need all the files within it. Okay, so once again, I've done this somewhere else. So what we're going to do is we're going to copy across a script I've already written. So cp dot slash, let's see what we've got here. I think it's under run dev test. Maybe it's RDT. Yeah, so I already wrote a script specific to that RDT02. I'm going to copy that across. I'm going to look at it now. Just a very, sort of commands in a shell script format. And that's actually going to work for us here, because what we're doing is we're doing an rsync. So we're using rsync to copy across the module. In this case, it's the same one that we want, and putting it in docker/modules. So just quit out that, we don't have to save it. So basically, just running that, it's going to create the general folder or directory that we need, and then it's going to copy the files into it. We said with a high level of confidence, and that appears to be what happened. Now, if we type tree for our build directory, you will see that we have got all of the files for the general module under modules, general, module/general. Okay, so we now have the files within our Docker build environment to be copied into a Docker container. So just remember those that last line, copy docker/modules into opt/pyscript/modules. We should copy the whole of the general directory in there. So now let's do our build. So I'll do Control R, Docker build. And that didn't take long because everything else was cached, and we simply moved our files. Now let's go in here and let's see if we can actually execute the script. Okay, and this will bring up something that is going to be the next thing that we have to add. So if we do Control-Shift-R, Docker run, that's probably going to fail, and it's going to fail because first of all, let me go back to 1. Just do Control-Shift-R, Docker run. Yeah, this is the right command for for this distribution because we have to go to bin bash. Okay. And so here we are. One thing to note, we haven't dropped into the right execution directory. We're currently in root. So we would have to cd opt/PyScript. So that's going to get fixed in a little bit. So no, I actually have a problem here. I actually have a problem. I haven't done what I thought I'd done. I must have, yeah, I made a mistake. I used the wrong build command. I built something. Yeah, I built the wrong container. I built this container of Docker.py. So let's go back over here. Let's get this right. Let's exit out. Let's do Control-Shift-R, Docker build, and build the right container. Okay. And we're going to run it. We're going to cd /opt/PyScript. Okay, so here we are. We have our pdb.py. But let's check and see which Python interpreter we're using. So we're using the standard Python interpreter in the container and not our custom virtual env one. And the way we can activate that Python interpreter command line, remember, I think we can take the source. It's going to have to be. Okay. So that's how you do it from the bash shell. Remember, instead of source, you have to use dot, and then the file name if you're using the Bourne shell, bin ship. So we're going to activate that. Okay, and now we can check which Python, and it's the refer to env Python. And now what we can do is we can execute our. Well, let's check our environment. Debug is 0. Okay, so we do env debug. So we're not going to debug. So we should be able to just execute the script. It will run through to completion without debug. And okay, so we have a problem here. We were unable to find that module. So that's a mistake on my part, but it actually illustrates the problem. So if we run the Python interpreter, if we import sys, check syspath, okay, what we're seeing is that we don't know where to find that general module, and the only way we can do that is to set Python path, export Python path equals, it's going to be /opt/PyScript modules. And now if we try to execute our, see it ran to completion because we set the Python path. So this now tells us that we need to set the Python path so that we can find our modules as part of the Docker build. So we're going to exit out of the Docker container, killing it again. We're going to edit our Docker file. And we are going to create an environment variable, Python path equals /opt/PyScript/modules. We're going to do one last thing. We're going to set the work dir to /opt/PyScript. Just means that when we drop into, well, it means more than that, but what we'll find it in the short term so when we drop into a shell, we will be in that directory. So let's do that. Let's build again. Let's drop into the shell. So you're now in Octopi script. And if we echo path, our value, if we okay, so but we're still not in a situation where if we were to run Python right now, we would run the correct interpreter. So how do we do that? Well, normally we would just we would have to activate the virtual environment, but there's another way. We can simply make sure that that Python binary is the first one to be selected in a search. So if we do which Python right now, it's the system-wide Python interpreter. If you look at that path, that's what we currently have. Now, if we were to place the path to the virtual environment bin directory at the beginning of our path, that would cause us to prefer the virtual environment Python interpreter. So we can type export path equals /opt/workend /bin $path. Now we can type which Python. You can see that it's actually now preferring our virtual environment Python. Okay. So we've done that on the command line, but we need to put that into our Docker file. So again, we're going to exit out. And this is going to be slightly changed. Refer to what we did here. This is how we do it. This is how we do it. So now we have set our path appropriately. Let's write that. Let's build it. Let's run it. Okay. I'll project it. That's Python P. Okay. So that looks good. Now what we want to actually do is we want to actually run this with the debugger. And the way we do that is we run a container, start a container, and we set an environment variable. And get /n. And let me refer to my notes. Always good to refer to notes. Yeah, here we go. And debug equals 1. Okay. So I guess we can just copy that. So that will start our interpreter, but it's going to override the default environment variable value. And if we do end, dev, now see that, so I guess dev was in that string, yeah, but it's also set to 1. So now if, okay, we type Python pdd /version, this is going to jump into the debugger. So we need to make sure that the debugger is listening. And so it is, it's running. There was a process that was connected which was terminated. But I believe that we should now I'm going to add a breakpoint just in case, but I think it should stop at the first line of code after the set trace command, so it should stop at this import sys. But let's go ahead and try this. That's good, looks good because it didn't run to execution. And we've got some complaints, but I don't. Okay. What it's showing me is I've got a mistype. I've got PyD Docker 01. Okay, so I've got a problem there. I'm going to control C that. I'm going to have to exit out. I'm going to have to find that PyD Docker. Yeah. So I'm going to slash. Okay. I have to rebuild. We're going to have to come back in. We're going to check our Python. Okay, I think we're good. Let's go across. There we are. You can see that. So just to go back to this, I'm not quite sure exactly what's going on, but I think somehow Eclipse tries to look at all the open files or something like that and tries to figure out, if they correspond to the process that has just contacted the debugger. So you're going to get some stuff like this, okay? But it did stop here. You will see that we have our variables, and we have our breakpoints. We should probably get rid of the rest of these actually. And we can step through. And this is a call to my my other module. So the important thing is, can you step in? And we can. Just a little function. And then we're going to step back out. I took out some code. I actually had some code that I took out, and I realized why I had it in there. And we will put it back in just to show you what it's about. So we're going to stop this. Okay, so that should, yeah, that ended. Very interesting, when you start the debugger, the function, the script runs to completion when you're remotely debugging. But we're going to go over and we had JSON loaded, and we had this little call to the JSON load S function. We're going to save that. So our code has changed. So we have to rebuild our container image. And that also makes me think about efficiency in terms of ordering stuff in the Docker file. So we're going to go back to the Docker file. And what I'm thinking about is the thing that changes the most often is our code once we're in a development cycle. So seeing as each of these commands in the Docker file builds up a cached layer of the container image, then the ones that it will detect that there's been a change in those files, and therefore it will rebuild starting from those copy commands. So what I'm trying to think about is, can I put those copy commands at the end? And I believe I can. So what I'm going to do is I'm going to take these two copy files and I'm going to put them at the end. Okay, let's try that. And we're going to rebuild again. Okay, so that's good. And we're going to come in again. Here we are. We're going to run our script with debugging activated. Okay, back in here. So what I want to do is I want to run to the call to the JSON load-s. And I want to make sure that I can step into a standard, module, as well as one of my own modules. So make sure that all of our debugger to, what would you call it? The mappings from the executing script to the debug server are good. So let's step in here. And that worked. We're in the JSON module. Okay, let's step back out. And let's just run to completion. Okay. So, okay, we're still in the container. What about that? Get Docker file. Here's our Docker file. Let's actually open it up in Eclipse. Let's go here. Unless we have to refresh this, I think. I can't see the refresh on here. It must be here somewhere. Refresh, there we go. In fact, okay, so now we've got Docker, we've got we've got Docker, we've got our Docker file. Interesting how that's still a little bit screwed up by this long environment variable. Let me end that and put that in. Oh, that's not fixing it, but anyway. So, just to recap, we pulled in our base image, which is Ubuntu, the Python built on Ubuntu version 2.8.2. We set our debug variable to 0, saying that under normal circumstances, when we run the script, we don't want to invoke the debugger. We install the virtual env package in our system-wide Python interpreter within the container. We copy across a file which contains a list of package requirements for our script Python environment. We create the virtual environment, and then within the virtual environment install our package requirements. We set some arguments which are going to be used in this path from Eclipse to Python environment variable, which is a list of mappings of directories in the two environments, one to the other. And we use the arguments for that. We set up our Python path so that it includes the modules that we're going to copy in, so we can find our own modules. We set up the general path so that our virtual environment Python interpreter is going to be found ahead of the system-wide Python interpreter and used when we just use the Python command. We set the worker to be our opt/py script, and finally we actually copy across our own files. So I think there's a little bit more optimization to be done using args, and then using the args to substitute into to certain places, but I think we'll stop there because this is probably already gone on for so long that no one will ever watch it. If you are listening still, I thank you for your patience, and I hope this has been of some value to you. This is all new to me, and it's kind of pushing out on the limits of my skills, so it's been quite difficult to work through this, and I hope this was as useful to you as I think it will be useful to me as I carry on trying to improve my Python programming and deploy my scripts into Docker containers.